This is lesson 12-6, measures of dispersion and distribution. The measures of dispersion describe how dispersed or spread out the values in any data set are. The three main measures of dispersion include the range, which is the difference between the highest and the lowest, the standard deviation, which is a measure of how the values in a data set vary from the mean, or how far they are from the mean, and the variance, which is just another measure of how far they are from the mean. It's actually squaring the standard deviation to give you the variance. Range is obviously a simple calculation in finding the maximum and the minimum of the data set, but standard deviation and variance should be found using the graphing calculator. The symbol in the graphing calculator for standard deviation is S sub x when you run a one variable stat when you put the list of your data set in the calculator. To find the variance from getting the standard deviation, simply take that number and square it. The distribution of any values in a data set can be viewed and described through the statistical graphs that we've already learned. In other words, a histogram, a box plot, and a dot plot. Distribution can be one of three things. It can be left skewed, meaning the tail is to the left. In this case, the median is greater than the mean. You can see the picture below with an example of what a left skewed distribution looks like. We also can have symmetrical distribution where the median is equal to the mean. As you can see, it looks like a perfect mountain or curve where we go up, reach a peak, and then start to come down on the other side. The last one is a right skew where the median is less than the mean. You should be looking for a right tail, as you can see in the lower right corner. Here are what box plots look like when you're reading distribution. As you can see from the top one, the median is right in the middle of the box plot, and the line segments on the ends are relatively the same length. With a left skew, you can see that the left line segment, or whisker, is shorter than the right line segment. It's the opposite for a right skew. The left one is longer than the right. Let's do an example. Complete the following for all of the data in the white box. I want you to find the range, the standard deviation, the variance. I want you to create a box plot and describe the distribution on the box plot. Pause the video at this point to give yourself a chance to try it on your own. Here are your answers. The highest value in the data set is 84. The lowest value in the data set is 68. Therefore, 84 minus 68 gives me my range of 16. Putting the list into the calculator and having it calculate the standard deviation, S sub x is equal to 4.95. Squaring that to find the variance gives me 24.5025. To create a box plot, I first need to find my 5-point statistical summary. If I ran the one variable statistics to find the standard deviation, the 5-number summary is also in the one variable stats in the graphing calculator. When I ran it, I get a minimum of 68, quartile 1 is 71, the median is 75, quartile 3 is 80, and the maximum is 84. I set up a number line with my minimum being at 65 and my maximum being at 85. I'll draw lines in between here to remind myself that that's 70 and that's 80. 68 is probably going to be somewhere around here. 71 just above that first line that I drew for 70. 75 is the median, 80 is the third quartile, and 84 is my max. To complete my box plot, I'll draw my box in between the first and third quartile, and I'll draw a line down the middle at my median. I'll then connect my minimum and maximum to the box. In looking at this to describe the distribution, it does look slightly right skewed because your right side, slightly left skewed because your right side is a little bit longer than your left side. However, this is as close to symmetrical distribution as you can get. The answer for this would be symmetrical. If you're having any issues with this particular lesson, please make sure you consult your teacher in class.